Okay, so binary and hexadecimal arithmetic. In order to perform arithmetic operations on binary and hexadecimal numbers, a straightforward method is to convert the numbers to decimal, operate arithmetically in the usual way, then convert the result back to binary or hex. It's not a bad way. However, arithmetic with all numbers represented by positional numeral systems can be performed in a familiar manner. We demonstrate this by example with binary, but this method also applies for hexadecimal arithmetic. It's just that hexadecimal overflows at 16 instead of 1. So, yeah. Good. So, summation and subtraction are pretty straightforward. Multiplication is too, but it's just a little bit more involved. Just like learning arithmetic for the first time. I'm sure this is, actually I'm sure when you guys learned arithmetic, they started with binary because it's simpler, right? And technically it is, but I don't think they teach it this way. Not where I went to school. Okay, so let's sum these, and you guys know what we're going to do. We're going to go ahead and write these numbers out in rows. So 1, 1, 1, 0, and then we're going to do plus 1, 1, 0, 0, and our good old-fashioned sum down the columns is what we'll do. 0, and starting at the right, 0 plus 0 is 0. 1 plus 0, 1. 1 plus 1, oh, we overflow. So we have 1 and a remainder of 1. And we have 1 plus 1 and plus 1, right? So we have actually 3. So 1, and you have to carry a 1. Oh, wait. I carried that wrong. I carried, but I wrote a 1 here. Whoop. Well, that was weird. There we go. So 1 plus 0 is 1. 1 plus 1 is 2. So 2 is 1, 0. And then you carry the 1. And then 3 is 1, 1. Yeah. So it's a little creepy and weird, but it works just like your other arithmetic with overflows and all that. Carrying. And we tend to write these things in groups of 4. So like this one, sometimes you'll see it as like there would be a little bit of a space in between. It's just because they write it in terms of grouping nibbles, because then you can put a hex character in there instead. Binary subtraction is next. So we'll do the same sort of thing where we draw the stacking here. So 1, 0, 1, 0. Subtract 1. Oh wait. I said subtract that from this. So 1, 1, 0, 0 from 1. So 1, 0, 1, 0 from 1, 1, 0, 0. Good. Okay. So 0 minus 0 is 0. 0 minus 1, we need to borrow. Dang, remember borrowing? Okay, so we borrow from this one. And now it's 1, 0, which is 2, minus 1, which gives us 1. Okay? So we borrowed this 1. So 1, 0 minus 1, so 2 minus 1 gives us 1. And then we borrowed this guy, so we have to just drop down to 0. And then we have 1 minus 1 is 0. The borrowing is kind of weird, but that's how it worked before too. When you borrowed, you got the 10 or whatever from the next guy, right? So so if you had an 8 and you borrowed from the next column, you would get 18, right?
So what if instead of borrowing at 1, there was just already a 0 there?
You have to borrow again. You have to keep borrowing. Okay. So you just as before when you had multiple zeros and you had to borrow from this guy, you have to borrow from the next guy, all the way down. You just keep borrowing. And in fact, I think, let me see. Yeah, we're going to do that. Not in this lecture, but in the next lecture, we're going to do that. So, yeah, something to look forward to. Yeah, that's binary subtraction.
So, excuse me. Okay, first.
Yeah.
So how you get? Can you explain more how you get the second one? Yes.
Yeah. So 0 minus 0 is 0, and then 0 minus 1 we can't do it because we need more. So we have to borrow from the next column over. So when we borrow, when we borrow from the next column over, we get the overflow. So when we were doing it, when it was in base 10, and say we had say 54 minus 18. 4 minus 8, you have to borrow, right?
14.
Because 4, and then this is 14. So you got 10 from the column over. In this one, you can't get in binary. You don't get 10. You get 2, essentially. This is base 10. You get 10. In binary, you borrow and you get 2 because you have base 2. So you don't have as much to borrow, but you don't need as much either because these numbers are all smaller. So, yeah. 2 is always going to beat whatever's below it, so in binary. Yeah. So that's how, and then we drop 1 down to 0 as usual. If you borrow from 0, it actually turns into a 1, which is kind of weird. But that was how, remember we borrowed from 0 in base 10, you got 9, right? There are only 2 options in binary, though. So, yeah. Okay. Binary multiplication. Multiply. Isn't it funny how much you take these things for granted now that were so hard to learn when you were a kid? And like when you have to learn them in a new base, it's actually kind of tricky. Like it brings back all those horrible memories of trying to learn how to multiply numbers together. Okay, so let's multiply these two numbers. I guess you would usually multiply a number by another number. Yes, so we have 1, 0, 0, and 1, 0, 1, 0. Either one can do, so multiply. Okay, it's the same procedure that is from before. Now, I know that some of you have used techniques, I know that way I learned did, where you have these trailing zeros out here and you just drop those zeros to the result and skip to the first time you have a non-zero in the multiplication. You can do that in this too, but I'm just going to dumbly just march through and multiply things by zeros a bunch of times because we're new to this. This is our first time. So I don't know about you guys, but multiplying binary numbers is not something I've done a lot. Okay, so we've got 0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. This is why we usually skip the zeros. Okay, the next row, and we shift over 1, remember, when we write the next row. So 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1, and 1 times 1 is 1. Okay. We have another 0, so we're going to have 0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0, and 0 times 1 is 0. And we have a 1. So 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. Okay, and then we have to sum these all up. So we get 0, 0, 0, 1, 1, 1, 1. So that's our result. So this is kind of the usual thing. And then you can do long division too. But I skipped that one because we have a lot to cover. So, yeah, but that's the idea. I mean, I guess I just wanted to demonstrate that you can do arithmetic and all these, and it's the same sort of procedure. But the overflows and the borrowing just feels a little weird just because that's the rules change slightly with a different base. Which is why a lot of times, unless you're feeling frisky, you just convert to decimal, do your arithmetic, and then convert back. Because I think that it gets kind of hard. But there are certain cases when doing it in binary makes sense, especially if you're going to be writing something that does a calculation a lot of times. Sometimes doing something in the binary form is actually better to do, more efficient to do. So it's useful to be able to understand how it works. Deepens our understanding of the whole thing.
Dividing?
Dividing too, I mean, technically, it's something that you might run across. It's once again very analogous to base 10 long division. So, yeah. All right, any questions on this? Okay.